The name of this presentation, APRS, what is it and what it is not? I think this is a good working title for this because even though it's been something that's been around for a long time, there's still a lot of folks that don't know what this is or may think they know what it is when it actually is not. And so that's what I'm going to kind of run through. So we'll dive right in here. So a couple things here as I start the presentation. I've broken it down into a couple different sections, but just some kind of high-level facts. It was sad 2 years ago, the inventor of APRS, Bob, who I've known for a long time, passed away. He's known for inventing APRS as to what we know it today. He worked down at U.S. Naval Academy. A lot of what APRS kind of started life on was tracking of ships and stuff like that. So really interesting guy. I don't know if anyone here has ever met him, but definitely a loss to the hobby. And so many of us that were close with him in the APRS inner circle are trying to carry on his work. So again, he started this back in 1982. Didn't really gain traction until probably the mid to late 90s. So if you've been a fan of Packet or BBSs from way back when, you may have heard of this. So it's been around for a while. It wasn't until probably just a few years ago that the name Automatic Packet Reporting System is the official adopted name. And as you can see here on this too many words on a slide, at its inception it was known as Automatic Position Reporting System. But Bob fought to change the name of what he invented because he wanted to get the point across. That is, this is not just for reporting of positions. It could be used for other things. He tried Automatic Presence Reporting System, didn't really catch on, but Automatic Packet Reporting System really is the way that you would want to think of this. It's also a mode which is based off of a standard called AX.25, which I'll come to much later. But when we talk about APRS tonight, this is what I'm referring to as an AX.25 based mode. And again, I'll touch that a little bit later. And as we'll go through, there's lots of other things that claim to be APRS, and I'll kind of dispel some of those different things. So if you're shopping for a new toy that you don't want your wives to know that you recently purchased, you know to buy the right thing so you don't have to return it or buy a replacement. Or maybe you wanted to do that all along. I don't know, but hopefully that'll be a takeaway for you. And then lastly, the way that I've outlined this presentation is really to focus on portable, mobile, and highly portable things. Certainly you could do things like APRS and Packet from home, but that's a lot easier to do. If you're trying to optimize to do things in a field, such as field day, then Joe BZB may have some distant memories of me driving around on a bicycle at the Limark field day, probably in like 2002 with APRS. So I go back that long, so I'm not a relative newcomer to the hobby. So that being said, APRS does not need GPS. That's the first thing that I want to really instill in everybody. There's many things that APRS can do. Only some of them involve position reporting. And most position reporting is based on GPS, but not all of it. And there's a really cool use case that I'll get to towards the end of the presentation that talks about how you don't necessarily need GPS as part of position reporting. It also is something, it's a mode, like a lot of digital modes, you do not need the internet. So the APRS can function without the use of internet. There are some applications that benefit from connecting it to the internet, but not always needing it. And then there's even some things where you need internet for 100% of the time. So this might sound a little confusing, but again, there's lots of different ways. And so please don't consider this as you need internet, because I know there's a lot of purists that say internet and ham radio is bad, bad, bad. So there's something in here for everybody. So a little bit about my journey. Like I mentioned a couple minutes ago, I've been at this for a long time. It was one of the two reasons that I made the jump from CB to ham radio. First thing was I'm an avid space guy. I grew up in Levittown, for those that don't know me. So as a kid, I was right in the shadows of Bethpage watching F-14s and E-2Cs fly out to Calverton for testing and stuff. So aviation was a big part of my life growing up. All my mother's family worked for Grumman or Sperry or whoever, so it was always kind of in my DNA. So everything space was always interesting to me. And wireless kind of bit me from an early age, and I'm sure there's probably a lot of you that have had the same. So The first radio that really caught my eye was the Kenwood D7. It came out in 1998. Took a train ride into New York City to Barry Electronics. Just a quick show of hands. Has anyone ever bought something from Barry Electronics in the city? All right. So we probably all share some stories. That guy, he didn't want to take the radio out of the stock room until I showed him a stack of cash. That's how annoying this guy was. So I showed him the cash. He got the radio, and then I spent the time on the Ronkonkoma line figuring out how to use this radio on the way home. So that was a fun. But then I realized I needed to get all these other things to go with it. As a radio, it did all the typical, talking and receiving radio stuff. But for me to get the maximum that I wanted to have out of this APRS-enabled radio, which was really nothing more than a 2-meter and 440 handheld with some ability to do some modem and packet stuff in there, there were other things that I needed to get the most of it. And so I found myself purchasing a Garmin GPS, which was a way to consume many AA batteries, as well as a small pocket organizer that I had that basically functioned as a terminal. So all together, and I tried to make these size to scale. So if you kind of think, this is as small as I got it, and this was like in the early 2000s, late 90s. So, really from a size perspective, aside from things being kind of attached into each other now, I had this down pretty small, over 20 years ago. And so, again, this was something that really kind of caught my eye. A friend of mine, I forget his uncle's call sign, but my friend Scott, WA2INP, which was his grandfather's call. Originally, I think he was KB2UZQ. He introduced me to his uncle, who played Packet with his 2-meter Radio Shack radio as a field reporter. So he'd upload and download stories and stuff to submit them wirelessly over 2 meters. And I thought that was like really neat in the late 90s, because we didn't really have mobile internet that was accessible. And so I thought, wow, if I can do that, but even smaller, all in, right? So that's kind of where I got my start. I was doing things like accessing BBSs that were still on the air at the time on Long Island to, grab down some internet files like Anarchist Cookbook and some other, strange things that people posted. So that was kind of a fun time. I can send and receive files. So I was able to do a lot of stuff. I was also able to bounce packets off of the International Space Station when it was not nearly the size that it is today. So I go back a long ways with all this. So just to kind of give you an idea, this is not something that's like a recent fad to me. I've been at it for almost my entire involvement in the hobby. So this is not real APRS. What is not real APRS today? These are some things that I just want to kind of further point out. I get all the negativity out of the way early on. Hopefully you'll all appreciate that. So the first thing is ICOM. ICOM, we all love buying radios from ICOM. They do not sell an APRS radio, and they never have. However, because they have D-Star, there's something called DAPRS, and it does much of the same functionality as APRS, but it's on their proprietary format, whereas something like APRS, it's not quite open, but it's way more open than something like D-Star. So for anyone who has an ICOM radio, the reason why you can't use D-Star to a Yaesu Fusion or DMR radio without some magic of the internet in between, it's a proprietary format. And so ICOM has never done that. So I just want to make that clear that we're all talking about the same thing. DAPRS is not APRS. The other thing, which is kind of like a relatively new thing, there's lots of radios that are made and manufactured out of China. Some, like you find on AliExpress or Amazon or whatever, they say, oh, it's ham radio, or it's GMRS, or it's both. Many of them say that they have GPS. They're not APRS, except if it says specifically on the package, or even the marketing doesn't necessarily mean that you're buying what you're buying. If it says that it has AX25, or if it has a KISS modem, chances are it's going to support APRS. So I really want everyone to understand that, because there's lots of really cool radios out there. There's some GMRS radios, as an example, that have something, it's almost identical to APRS. But since they didn't license it, they're using different speeds that are not standard in amateur radio. So again, the big takeaway here is just be careful what you buy. If you do want to get involved with something like APRS, make sure you're buying the right thing, because otherwise you're just going to have a lot of frustration. All right, so the next three slides is how do you actually get involved into APRS? And notice how I haven't even explained what APRS is. So this and the next two slides are like the cheapest ways to get involved. So the first way, everyone has a smartphone. I'm sure everyone has a Baofeng whatever radio. If you want to claim that you have one or not, that's up to you. But you could basically buy an inexpensive cable. There's most phones these days don't have like the 3.5 millimeter headphone plug. Most phones, if you want to do audio devices, especially if you have like a USB-C port on the bottom of your phone, there's adapters that you can basically take a cable, plug it into the USB-C port, and then it can connect into like a radio, like a Baofeng. And there's cables that go for many other radios. And basically the way that this works is it's using software on your device to do all the heavy lifting, to do APRS. It's not the best way to get started, but it's enough to give you some like really good proof of concept. Just with a quick show of hands, does anyone here have the APRS Droid application on their phone? I see 1, 2, 3, 4, 5. All right, cool. So, all right, so we have some people out there that have probably played with this. And as you probably know, it's basically using voice activation to do the triggering between receive and transmit. So if you're looking for longer range due to weak signals, or even if you're in a dense signal area like in New York City, this is not the best way to go about it. But again, it's really great to get started and just to kind of get an understanding for what it is. So the next step up here is through a device called a mobile linked TNC. They're up to their third version. It's been around for, I don't know, however many years, but the latest version is TNC 3 that has some really cool stuff that we're not going to talk about today. But essentially what this does is it plugs into your radio, and they have all these different cables that you can buy for it. You connect it into this little box, and then it creates a Bluetooth gateway to your cell phone. So it actually does all the heavy lifting of encoding and decoding APRS packets in the little TNC device itself, and then it's pairing over Bluetooth to your smartphone or even to like a real computer. So as long as you have a Bluetooth enabled device, you could use this with like the APRS Droid app or some of the other software for full-size computers. I think this is probably the best way to get started, and just to give you like some additional utility, and you could probably all poke Ed because I know he's very involved. The guy behind Mobile Linked, Mark is his name. He's also built on some firmware that supports a digital voice mode that's also digital data capable called M17. So if anyone has already seen Ed on some of his different YouTube videos that people pull him in on, this is another way to actually get started with M17, which is kind of cool. And I like this as an option if everyone's not really into soldering or building things. You just go online and you buy it for the appropriate radio. Maybe you buy like 1 or 2 different cables for different rigs that you have. You can use it with handhelds, you can use it with mobiles, but this is a really great way to get started with APRS on the cheap. And then finally, the third cheap way here is to a radio that I can almost guarantee that nobody's ever heard of. And if you have, most likely you've come across one of my posts or blogs or something on that, as well as other people in this community. So it is a Chinese radio named the Launch HG-UV98. The way that you want to think of this, it's like a Frankenstein Baofeng with the insides of like some really cool APRS related stuff that's also sold by another company. And so as a cohesive in one box solution, it's actually a really great radio. I think they still sell for like $150 US, which is not that bad considering. It's a 5-watt HT, 2 meters 440, but what really sets this apart is that it is a full functioning APRS radio, has built-in GPS, has Bluetooth, so you could operate this as a tracker. Say if you're doing a public service event like a Wounded Warriors run or something like that, and you wanted to track your locations, you could easily equip a team with these on the cheap. So it's a really great radio for that. That's one of the radios that I have. I think it's one of the only non-stock photos that I have in this presentation. So it's really cool. The only thing that I would say about this before you go and hit the buy it now on your way home is, while it does support the KISS mode, which I will explain that in a few slides, there's been some issues with, I don't want to call it quality control, but with supply chain. So over COVID, they made some changes, and there's been many reports, and we have a tracker of serial numbers of like what batches of radios had a certain function and what radios didn't really support that. And so I believe the latest ones, if you were buying them today, they've resolved that. But there was a time between like 2022 and 23 where there are some weird anomalies. So again, if you're interested in this, you can do some research and you could find out a little bit more about this. But again, I think all three of these are great ways. You probably already have like one and a half of these things already. I say the best way is get all three of them. But again, these are three cheap options, you know, for the cost of a Baofeng and a cable should set you back like $50. The mobile link TNC I think is like about 100 and change, or you can get this radio. So there's something for everybody. But beyond the cheap side, right now I would say the way that you want to get involved in an APRS, there's a few things out there that I personally recommend. Kenwood was an early adopter of APRS as a standard, and so they've always been considered the leaders when it comes to anything APRS. So when I say a gently used Kenwood TM D710 AG, which was their last mobile version that they had, that has like a GPS and stuff built into the head. But then there's older versions, the D710A, the D700. You know, look for like a gently used one, like on eBay. And as with most Kenwood stuff, they still command a premium. So, you know, like the early D700, you know, we're probably pushing 20 years old at this point, and they're still commanding pretty decent prices on the used market, which is kind of insane, but it's a good quality product. On the left side, this is a current production radio made by Yaesu. I'm only using this as an example, the FTM 300, because I like the form factor of it, and this is the reason why I bought it. But the FTM 500, which is that big knob radio that everyone laughs about, it's basically the same thing. The FTM 6000 minus like some dual band and color display, it all basically does the same thing. They all have APRS, but one of the challenges with Yaesu radios is it's not the best radio for APRS. It will function as like a tracker. You can see people's positions, you can send text messages, you can do all this stuff, but it does not allow you to do some of the more fancy things that a Kenwood radio can do, and then you need to actually buy an external TNC. This has to do with how Yaesu licensed or didn't license things. But again, this is not going to be a negative for most people. But I do want to kind of mention that if you wanted to do advanced things, you may need to hook some other things up to current production Yaesu radios. And then finally, I call it the new hotness. This is the Kenwood D75. They had the D74 out for a couple years. Their factory burned down, and then they decided to add some extra functions, which I'll talk about a little bit later. But if you want like the solve-all end-all of handheld radios that does most everything that you're ever going to probably want until they come out with something even better, the Kenwood D75 is worth the expenditure if you're looking to spend $800 on a handheld radio. So if you want to get started, these are the things, just again, to put these prices into people's minds so I don't oversell you on technology, and then you realize that you got to spend some bucks. So I figured I'd do this in opposite. So some obligatory slides on software. So with most things, a bunch of you have the APRS Droid app. There's also desktop versions. So if you have a Windows computer, Linux, Apple, you know, there's different versions that you can set up in different ways. The two pieces of software that I like, Pinpoint APRS, which is over to the right. I think that has a little bit more of a modern feel. I personally prefer that. But the piece of software that's been around since a long time is continued to be under development and actually works extremely well is what's called APRS ISCE or ISCE 32. You can hit the URLs. I'll share the deck with Ed, and he could punt it out to you all through the website to take a look. But these are all great pieces of software that allow you to do some other cool things. So that's that. And then there's a lot of different websites that relate to APRS. So I call this the obligatory APRS.fi slide. It's not .com, .net, .org. It's APRS.fi. You go to this. It's going to show you access to everything. I did a screen grab yesterday. This is kind of what you're expecting to see like on Long Island. So it's not just like ham radio people driving around or Digipeaters and things like that. There's other things that APRS-FI ingests. So there's weather stations. If anyone uses Wonderground, some of those weather stations that contribute to websites like Wonderground actually show up on the APRS-FI website. There's also boats and maritime traffic that show up because there's different receivers that take AIS plots from maritime traffic and throws it on here. There's all sorts of stuff. Sometimes when people do high altitude balloons, out in your neck of the woods is Joe, WJ2B, who I don't think is here. I didn't see him, but he's like the high altitude balloon guy of Long Island. So anytime that he's tracking something, or maybe he decides to launch another one, you might see it on APRS, because that's what people typically broadcast. So APRS-Fi and other sites like it share all sorts of things, and I'll get to exactly how that happens. And then as we kind of move on here, one thing that I think is a little unique with APRS is you can actually use this without a radio. As we all have amateur radio licenses, certainly if you run the risk of having a signal come from the internet that could potentially make itself out over RF spectrum, that's like a big no-no. And so they have like this special 5-digit code thing where you can register on the aprs.is.net website. You get this 5-digit code. You put that into the APRS Droid app or the other 2 pieces of software, and it allows you to actually, from any computer with internet access, replicate as if you were on the air. And so as an example, say if I just had my cell phone and I wanted to send a message to Ed, and I knew that all Ed had was a radio, there's ways that I could actually do that and message. And that's actually kind of neat. So aprs.is, and I don't know how big the screen is that you're all looking at me on, but the bottom right image, just to give an example, I convinced my wife as a birthday present that we were going to take an open air biplane out of old Rhinebeck Aerodrome last summer. And so I knew that having open air pit was not a smart idea to have a radio squawking location. So I secretly put APRS Droid enabled on my phone, and it was able to track the location. And you could probably see if the display that you're looking at is large enough, you could see my flight path going over the Hudson River and doing some loops and stuff like that. And then the upper one, just because it's nice to pick on Ed every so often while we can, I found like a grab, and like you can do and query people's call signs. So like if you look for like into XDD and then put a star after it, you'll see all of the different versions of APRS through SSIDs, which I'll explain next, how prevalent Ed is as a user of APRS, or even myself. So if you do a search for K2GOG with an asterisk, you'll see all the different activities that I've done, and you can do all sorts of cool things. So again, APRS-Fi and APRS-IS, definitely check it out. You can play around with it, and you don't even need to buy anything. So all right, now it's really time to talk about APRS. Hopefully we have some 90s people in the audience that would get the album cover. I'm not going to say the word that I replaced, but you can probably remember this and why I thought it was fun. So little clever little nod to Star Wars, Master Yoda. No more not, only do, and maybe try. Obviously, I changed that to apply here, but now we get into the real meat of the presentation. So came up with 5 really cool things that you can do with APRS right now, and I'll spare you my Master Yoda impression because it's horrible. So all right, but before we do that, I have to go back to something that I made mention of earlier. AX.25 as well as KISS. And no, we're not talking about the band. I spared no expense. I gave you the best. But if you really want to dive into the nuts and bolts of what's behind APRS, you can go and look for this. If you look on Wikipedia through AX.25 or what KISS is, they're very similar. But this is like the inner workings, the plumbing, the inside. For most users, we're not going to really need to care about a lot of the code and packet headers and footers and bodies and payloads and all these technical terms. But for anyone who wants to do that, you could easily go and grab that. And I'm happy to chat with anyone as like a follow-up at some other point in time. But there's lots of presentations that do that. They put everyone to sleep. They're boring. I don't think this audience probably wants to dive into like those technical nuts and bolts. I want to get you understanding like how to use this and how cool this is. So now we go to the first thing. So APRS cool thing number 1. Let's say, for example, you see a friend on a map display. You can send your friend a text message, and then maybe since they're driving, if they set their radio up correctly, maybe you get an auto reply that says, "Hey, sorry, I'm driving." Many APRS radios you can set up smart functionality like that, which is pretty cool. You could also even set things up where maybe if a friend messages you, you can have your radio, in many cases, change to a specific frequency, and you can see what repeater somebody's using. So there's lots of really cool things that you can do. This is pretty much like what I would consider the basic. So the main frequency for APRS in the US is 144.39 megahertz. There's kind of three ways that you will most likely be utilizing APRS. The first method is radio to radio. That's like if maybe we're at a ham fest and I want to share my location with Joe BZB and he has a radio and we can see where each other are, and maybe we just only want to know where each other is. We can go and find some obscure frequency and just share our location with each other, and we don't necessarily need to use the common APRS channel. So that's one way. This all works without other infrastructure. You can do radio to radio. Second method is you can use radio to digipeater to radio. So a digipeater is just like an analog repeater, like you'd have, spread all over on Long Island, and most of them you never hear anybody on. So there's lots of digipeaters. The Larkfield Amateur Radio Club on the North Shore probably has one of the more prevalent APRS digipeaters in the Northeast. Chances are, if you have an APRS radio, you basically bounce your packets off of that, and then other people could receive it. Then there's a third method where then you go radio to digipeater, and then some digipeaters have what's called an iGate. And an iGate is just like a fancy term to say that that's their bridge to the internet. And so let's say, for example, if maybe Nikole went on some trip to California and I wanted to send her text messages back and forth over APRS. There's ways through the magic of internet that can route those messages. And I can send messages to Nikole, she can send messages to me, I can see her location, she can see my location. And so then you're using basically radio to digipeater to an iGate, and then maybe that bounces back out somewhere in California via a local iGate, which is connected to a digipeater, and back out to her radio. So those are probably the three common ways of, if you want to be focused on exchanging messages, that's how that kind of works. Now, there are a couple parameters. This isn't just as easy as turning your radio on and getting it to function. There's some extra programming that needs to happen. So the first term, if you're not familiar with APRS, is you have an SSID. So this is not like an SSID that you have like for your home Wi-Fi. This is like a simple 1 or 2 digit code that represents what type of use case you're using as APRS. So as an example, if I am walking around with a handheld radio, my SSID would be my call sign K2GOG-7. Then maybe in my car, I use -9. If I'm doing some kind of a balloon experiment or something, I might do 11 or 12. And so there's 16 different options that you can select from. This pretty much covers all the use cases. And so you can have multiple radios doing multiple things with APRS. So this is something important to know about, is SSIDs. And then this graphic, I really, really like. This explains what a digipeater is. So if you look at the graphic, let's say you're the mobile operator, and you're sending your signal. So it's going to bounce off of a close digipeater, then it's going to ricochet off of the next one, and then reach a wider area. And so how this works is what's called a path. So in your radios, you will set different paths. So if you can see the graphic going, if you set a path called wide 1-1, that's only going to go 1 hop. If you set it for wide 2-1, it would go up to 2 hops. So you might think, well, we're all amateurs, right? We all have the dreams of the 1.5 kilowatt amplifier and 10 element beam on 40 meters or some crazy stuff, and you want to go all over the place. Well, with APRS, you don't necessarily want to do that. The challenge is since for common use, there's only one frequency. If everybody in New York wanted everybody in California to know where they are, and you hit 7 or 8 hops, you're going to congest the single channel. And basically you get network congestion after roughly about 3 hops. So you always want to set your path to low. So I would suggest wide 1-1, wide 2-1 at the very max. Probably 2-2 if you're in some sparse area, like maybe like the middle of nowhere, Arizona. But for the most part, you never want to be there. The point is, there's so many digipeaters in the United States. I would challenge most people to find an area where there's not coverage of some point that you could reach out to some digipeater, and that's actually pretty neat. So all right, so closing up on cool thing number 1, we talked about how will it work radio to radio, important things to know. Talked about frequency. We're using the speed of 1200 baud. Most radios, with few exceptions, support a faster speed called 9600 baud, but for the most part, that's never caught on because it's more complicated, and I won't get into that. But basically, we're communicating at 1200 baud. really to send your location and a simple message. We're talking like less than a half a second of a transmission, really, really short. This is also the bandwidth of your radio is really important. You have to make sure that it's like wide. We're grandfathered into using wide where the commercial industry is at 12.5 kilohertz. So your radio should support wide, and chances are if it's a ham radio, it should, no problem. And then I already talked about paths and call signs. So that's basically, how you would want to kind of get this set up. And like I said earlier, maybe if you were at like a special event, you can use other frequencies. You're not going to have the benefit of Digipeaters and all the other stuff that are all 100% of the time parked on 144.39. But I just want to get that point across that you can use things without infrastructure. You can use things without internet when it comes to APRS. All right, so cool thing number 2. This one you may have seen in the blurb that Ed or Nikole or whoever sent out. This past weekend was an event. It's an annual event called Appalachian Trail Golden Packet. This happens every year in the most annoying part of the year in July. And in this photo, I'll give a shout out to Aaron and Stephen Hamilton. Stephen, KJ5HY, is Aaron's dad. Stephen works for United States Military Academy, aka West Point. I've known him for a number of years. He's one of the followers of Bob, who invented APRS. You can do a search for him. You'll probably come across a bunch of presentations, much like myself. I know some people have met him at various STEM-related things. All-around great guy, very visible out there. And so I was not able to participate this year due to a prior commitment. Stephen stepped up to take my spot. And then as an extra body, John, KE2X, also known as the Paluch, that's his Jeep. And so the 3 of them were at one of the 15 spots that we had for Appalachian Trail Golden Packet, also known as ATGP. So that happened this past weekend. And what is ATGP for those that don't know it? So this is an automated relay of APRS messages between 15 stations spanning 2,500 miles. So all the way from Maine all the way down to Georgia is the Appalachian Trail. And so with these 15 stations, we're able to cover that. And this is just basically one radio talking to another radio, talking to another radio. So there's no infrastructure at all involved. We run this on a different frequency, so it's not on the standard 144.39. I'll explain why in a moment. But this is a really cool event. It was one of the things that Bob Bruninga really thought could be something really cool with an amateur radio to show the different use cases. And so it's really been awesome to be part of this on and off over the years. Now that I live in Poughkeepsie up here in the Hudson Valley, it's a heck of a lot closer for me to either Man, Sam's Point, or Bovina as two of the local sites. But it's a hard event. Trying to plan field day, that's one thing. Trying to plan something like this with this many people spread across different locations and to all be in the same spot at the same time is crazy. But we're able to do this every year. So this happened this past weekend. And again, how this kind of works, going back to what I said about what an iGate is. So iGates listen for traffic. So if you see where that purple arrow is, we had one iGate set up because we wanted the world to see what we were doing. And so we set up an iGate to take our secret frequency and then share it back out over the internet so people can see what we were doing on APRS Phi website, so they can see how the event was unfolding. The reason why we like to do it that way is this way we don't get any rogue operators, as some of us have known. People get excited, then they start sending packets all over our frequency, and then it breaks the network while we're trying to set things up between all 15 of these sites, which usually takes about 30 minutes or so for people to get everything all aligned. So, but this year it was a fantastic event. Worked off without a hitch. Had some weird weather in certain spots along the 2,500 mile trail. One guy in particular up on Katahdin in the Northeast. He hikes up there every year. He's not getting any younger, so any of you younger hams in the audience, if you want to be part of this, we can find a spot for you. But he needed to get off the summit because it was getting pretty gnarly up there. So there's lots of cool people that are involved, and that's what amateur radio is great for, right? It's people all over the world that you make great friends with. And so many of us have met each other in person. Some we've not, but we're all bonded through amateur radio. And like I said, we're using a secret frequency. The one thing that I'll mention, getting a little technical but not too, is since we're not using Digipeaters, we can't use those paths called like wide 1.1 or wide 2. This is functioning different. And so we have something that we call hop. So basically, if you look towards the upper right of the map in Katahdin, basically every station has like hop 7-1 all the way through hop 7-7 all the way down through 7-15. And so basically, if somebody was to transmit up at Katahdin locally on a different radio, it would bounce off of Tim's radio at Katahdin and go all the way down to Klingsman Dome in Georgia. And so it takes about half a minute for signals to go from one end of the chain to the other. So hopefully that explains a little bit about it. It's a weird event, but it's like one of those cool things to say, hey, we can set up really wide scale networks. And if you wanted to do something like this on Long Island, like a bunch of you, if you wanted to do like low power 70 centimeters from like one end of the barrier islands to the next, you can do that, and you can set something up similar to ATGP but on a much smaller scale. Something that we did 3 years ago with the event was we've become dependent on Kenwood radios. The unfortunate thing is the Kenwood D700 series is no longer manufactured, and this was always a great thing because it's the only self-contained radio that actually has Digipeat function in it. So you could create a Digipeater with this. You don't need external stuff. You just hold some buttons down and it enables that mode, and it's great. And so that's why it's been really awesome to use for the Appalachian Trail event, because it's all self-contained. But because that's no longer manufactured anymore, we needed to come up with something else. And so a few of us got together, threw a bunch of ideas around, and so we came up with something a little interesting, a little technical, but basically it takes like a Raspberry Pi computer with an interface that you connect to your radio. And then there's some magic software by Andrew WB4APR called Direwolf. Could I get a show of hands? Has anyone used Direwolf before? I see one. Okay, and that's what I kind of expected. So what Direwolf does is instead of using hardware to decode and encode APRS packets, it's all done in software. So it's actually really cool. There's so many neat things that you can do with this, one of which I'll get to in a few slides. So we came up with this thing called APRS Appliance. Don, AB1PH, is who gets the ultimate credit for it. And so when we do ATGP, we now have 2 different time slots for it. So we'll call APRS Classic using things like the Kenwood radios. And then for people that are experimenting with the APRS appliance, then we have a different time for that. And so far we've gotten it, this will be the 3rd year. It's working pretty good for people that have adopted it. And so many sites have both. And so that's even another less inexpensive way if maybe you have like an old Motorola CDM 750 kicking around, or some old ancient ASDEN radio or something. You can actually take one of those radios, connect it with APRS appliance, or there's other devices out there too, but this is a full software stack and it's really customizable, and so it could be something worth looking into. It's called APRS Appliance. So that's that. And that's it for ATGP. Switching gears, we have Space Station. So the Space Station has a Digipeater on it. Coincidentally enough, it's a Kenwood radio. They turn it on to Digipeat mode, and every time that the ISS flies over, which actually should be happening roughly right around now, if I remember looking at the plots earlier, the ISS should be passing over. If I was not given this presentation, I could have turned my radio on, sent a packet, bounced it off the ISS. Instead of using a path like wide 1.1, we would use the path ARISS, which tells it that it's a terrestrial signal bouncing back down. And then you can actually see this. So if anyone in the audience is cell phone equipped, if you go to aris.net, so ARISS.net, if you go to that website right now, you'll see who was last heard by the International Space Station, and then whatever message that they sent back down. So it's pretty cool. Even if you don't want to talk to anybody, next time that the space station's passing over and you have APRS stuff, you can bounce your signal off, and you'll see yourself basically getting an echo back down, and then maybe somebody will call you back. Another ham on the ground. The astronauts, I have not come across them using Digipeater stuff, but they sometimes do a voice contact. But that's cool thing number 3. Number 4, I loved putting this slide together. I started off thinking number D instead of number 4, and then I thought DO. So of course I had to, give a shout out for one of my favorite bands. I have a feeling some of you folks with like the big beards and stuff are probably DO fans as well in metal. So Thursday is what's called APRS Thursday. This is something that started just a few years ago. This is something that is an internet-enabled only function. So instead, for example, when I send the message to Ed, where instead of me putting N2XDD-9 as the destination, instead I would put in ANS RVR. And what that is what's called announcement server. My friend Lynn down in Foreland is the one who came up with this thing. And so basically, you send the message to announcement server, and on Thursdays, you start your message with CQ HOTG, and then you can type whatever you want, like I like pizza, I like bagels, New York Mets are horrible, whatever, right? You send it to that. Then what's going to happen is your local Digipeater is going to receive that, and then for the next 24 hours, everybody who's part of APRS Thursday, you're going to see all those messages coming through, no matter where they are in the world. It could be somebody in Turkey, somebody in Australia, could be California, wherever. And then you'll see all these call signs bouncing in to your radio, and then you can respond to them if you want. And so it's kind of like creating DX with this weird like internet buffer in between. And so that's something relatively new. It's only been out for a couple of years. But I thought this would be really good to mention here because announcement server can be set up for other events. And so maybe if there's like a marathon or something, you can set this up. You can have it go out over the common frequency, which is what I would suggest on 14439 versus a discrete frequency. But there's lots of ways you can configure it. But the key thing is it gets everyone on the same page. And that's like what's pretty cool. So you guarantee that everyone's getting the messages. And then starting to close things up here on cool thing number 5. This ragtag bunch of folks, including myself and Ed, and John, who you saw in the Jeep Tenna photo, along with a bunch of others. This actually started as a cadet project. Nolan, now N2WU. He wanted to do something. Again, he's been a ham for much longer than you'd think. He came up with some weird details that he found through one of Bob Bruninga's weird notes that he had. He came up with something called APRS touchtone. And so when I said earlier that I would talk about something that does not involve GPS but can do location, that's what APRS touchtone does. The article from this photo is in the July 2023 issue of QST. Took a little while for them to get it like in train because it was a long article. But if anyone wants to go to the League website and download a digital copy or go and look through it, yeah, this is the group. So I think all of us were mentioned in the article, if I remember, by call sign and whatnot. But this photo was not part of that. You'd have to look really carefully. But my friend Dave, K2JLV, was doing rabbit ear fingers behind my head in the photo. So you're the only ones to see this. So I promise something special for you. And as you can see, we had a pretty diverse group of folks participating. In this case, was to support the triathlon. Oh, the details will be better read in the article, but just to kind of understand what this was. So basically what we did in our command center, we set up a laptop hooked up to a Kenwood radio, and we ran the Direwolf software. And the software has a touchtone decoder, DTMFs, right? 1 through 9. And so we wanted to equip people at the different waypoints during the triathlon course. And we didn't have enough expensive APRS radios to loan out to people, but everyone had a Baofeng. So basically we had everyone with a Baofeng, and at these different mile markers, as runners would come past and they'd have their bib numbers, right? Like, 551 or whatever on their bib. As the lead and last runners came by, all it was people would just use their Baofeng radio. They type in a DTMF touchtone sequence, like 12*551. And then that would get received by the main base station, and then it would echo back in a text to voice that it was received. And so it was a really novel way to do APRS really, really cheap. And the way that we were able to do this was because we knew the exact location of the waypoints. That's how we were able to just link the waypoints to a code. And so if we knew that this was at mile marker 5 and runner number 551 came past them, all somebody with a radio had to do was type that in, and it automatically showed up on the map. The output of this, again, I apologize, I don't know how large the screen is. This is like the text output of what was going on behind the scenes, but ultimately it ended up just populating out on a map like this. And so it was really cool. We got real-time reporting with minimal complications. We didn't have anyone screaming the wrong information into a microphone, confusing people. It took out a lot of the human element, which is actually what we wanted. So we were just dumb idiots punching buttons into a radio, and as long as we punched in the right buttons, we had the reporting that we needed. And so again, I would certainly invite everyone to look at that article in July of last year's QST if you want more information about that. And then we're 2 slides away, and then I guess we'll take some questions. So earlier I mentioned DMR. That's a digital voice mode. There's some capability that you have to do other things other than digital voice. Much like ICOM has D-Star, there's DMR radios that have something called DPRS, so they dropped the A, so they call it DPRS. But because it can use some magic of internet, I'll show you this video, see if this works. Oh wait, I gotta click it here. There we go. So I'll let this play through. Here I have a cheap TYT MD380. I was at the Croydon train station, believe it or not, when I did this. So what you're probably seeing on the display is me fat fingering the buttons to type in the term weather, WX, and then I'm going to eventually type in GPS. So it takes the GPS out of the radio and it sends it to a special talk group, again, over the internet. So in this case, I sent it to 262993 was a special talk group set up for this. And then it would send it, it would route its way back through the magic of the interwebs, and then it sends me a message back. And so I could read it, and it shows my reported latitude and longitude. And then I'll wait for me to get to it. There we go. And so I'll scroll down, shows exactly where I am and what the weather was in terms of temperature, humidity, barometric pressure, and wind speed. So this is something that you could actually do on any APRS radio, but I wanted to just show this as a demo of doing something like this over DMR. You can't do this with Fusion, you can't do this with ICOM D-Star stuff, but it's something just to kind of show that there's ways that you can glue together different technologies. But I almost intentionally want to confuse you that that's not really APRS. It's an APRS-like thing. And there are DMR radios, which I think is worth pointing out, that do actually support real AX25. So show of hands, I'm giving you all an arm workout. Does anyone have the Anytone 878? No? I see like half a hand and 2 hands. All right, so if you're looking for something to do other than listen to a worldwide 91 with the same 5 people on it, this is something that you could experiment with. If you get caught up, you could feel free to ping me. But there's some cool APRS stuff that you could actually do with those radios. You could do this, and you could do all the stuff that I've talked about before. There's nothing else that can do that. Once M17 mode finally, figures out what it's going to be, it does support a lot of this. But for now, if you want to see like a blend of APRS and some kind of digital voice radio, I just wanted to show that you can actually do this. And then finally, I think that's the last slide. No. Uh-oh, what's going on? Okay, there we go. All right, so final countdown. What's next for APRS? This is not just the end of the line for APRS. A couple of years ago in Europe, one of the challenges is they have less spectrum. Their 2-meter band's only 144 to 146 megahertz. We're fortunate where we have 144 to 148. For 70 centimeters, we have 420 to 450 in most parts of the country. They only have 430 to 440. And of those 10 megahertz, 3 of them are wiped out for satellite. So they have less spectrum. And so what a couple people started to realize was, instead of having Digipeaters that cover wide areas on 2 meters, taking up precious spectrum, they started to move them to 70 centimeter band. And when they realized that 70 centimeter band, they can get these little cheap SB32 radios, which is something that I think Ed was probably hitting on a little earlier, of like Hacker and STEM and Maker. These are all things like we all were exposed to and played around with at the Hope Conference last weekend. So you could buy these little cheap SB32 radios. They're like 15 bucks a piece. You could run some code on it, and you could technically make an APRS radio. They don't make those for VHF. They do make them for UHF. So in Europe, they started to repurpose these little inexpensive radios that are like 50 milliwatts or less output power. And they realized they're not going to get much range, because FM at 50 milliwatts, we all probably know, you're lucky if you go down the block, if you're lucky, right? But what they realized is you can use some other technologies like spread spectrum mode, like LoRa, or if people know what Meshtastic is. Does anyone know what Meshtastic is? I promise last hand raise. All right, so like 3 of you probably know what Meshtastic is. So it uses LoRa, and the cool thing with that is it's a really low signal to noise range mode. So you can get like 15 times longer range compared to what you would have with the same amount of power as compared to FM. And so across Europe, there's all these different stations, and you can look for them on APRS-Fi. They're using these LoRa APRS. So it's a whole cottage little subculture of people doing code on these devices, walking around with these little trackers, reporting their position and sending messages and all the other great stuff, but using these really inexpensive radios. So I think this is really where a lot of the future is going to go as we adopt and look at new modes. This is something that LoRa has already become pretty prevalent within the UHF spectrum. And so I think we're a little bit behind here in the US, but maybe we'll eventually catch on. A few of us here in the States have been playing around with this LoRa stuff. It's not APRS. It's something a little different. Just kind of getting my own shameless little plug-in here, as well as for my friend Joe, NE2Z. We came up with something called HASviolet, which is basically doing the same type of stuff as Packet and APRS in a slightly different form factor, using Raspberry Pi as well as SB32 devices. That's like its own presentation in itself. But, in kind of closing things out, I just wanted to kind of impress upon everybody that even though APRS has been around since almost 40 years in some form or fashion, now we're starting to see the evolution towards something else. And so there's nothing that you're ever going to find a lack of interesting things to do in this hobby. But if you wanted to try something new, you have LoRa, APRS. If you want to do other stuff that is kind of data-based, you can do that. But again, thank you for the time. That concludes the presentation, and I'll stand by for Rotten Tomatoes thrown at me during Q&A.